to this morning class. This morning we'll be looking at this morning we'll be looking at okay okay yeah, good morning. How are you? How was your night? And how are you today? Hope your night was fine and good. Okay, you are welcome to this morning class. This morning we'll be talking about Simpson's rule in Trig and Analytical geometry. Be very brief in the introduction. The introduction is here, then we'll go ahead to solve a few examples. Is that clear? Please don't forget to attend the class with your number. It's very important. Comment, like, and share. Is that clear? And if there's any question you want to ask, drop it in the comment section. Thank you. Okay, let's briefly explain the reason why Simpson's rule is applicable in trig and analytical geometry. Amen. As long as mathematics is concerned, there are some definite integrals that need quick approximate, and that is where the Simpson's rule will be applicable. Is that clear? So when you look at the board very well, you can see with me that Simpson's rule sometimes referred to as the parabolic rule. Parabolic rule. It means parabolic rule is the same thing as Simpson's rule. Okay. This will provide us the method for approximating the value of a definite integral. It provides us the method for approximating definite integral. You were taught what definite integral is all about, two of us. When we say definite integrals are this from running from A to B, f of x dx. We call this definite integrals. It means it has lower and upper limit. Is that clear? That is what Simpson's rule is trying to tell us, that it helps in approximating definite integrals of this form. Simpson's rule gives a better approximation than the trapezoidal rule. We also have trapezoidal rule. It's almost the same approach, but a little bit different. In a given interval, A, comma B, these are the intervals that you see, the limit. In this method, the interval A, comma B is subdivided into n equal subintervals where n is even. You know what's even numbers? Suppose h is equal to b minus, this is the upper limit, and y this is the lower limit, all over 2, and si is equals to a plus I h. So, should in case you are asked to write a short note on Simpson's rule, you can briefly give this. It's okay. So, let's go ahead to solve some examples. Please try to tell others to be part of the class this morning. Inform others, those who are still sleeping, inform them. Yeah, so let's proceed further to solve some example. Please like, share, comment, and you can also fix idea with example here. Another example says evaluate example. Evaluate integral 0 to 6 x all over 1 plus x squared. Amen. By using Simpson's one-third rule. Now, okay, by using Simpson's one-third rule, as simple as ABC, we'll look at it together. Is that clear? Okay. Simpson's one-third rule. Okay. Okay. So let's proceed further. Let's write solution. The Simpsons one-third rule is simple as ABC. That is, the formula is that is integral 0 to 6 x all over 1 plus x squared is equals to 1 all over, that is h all over 3 open brackets, sorry, h all over 3 open bracket y not plus yn, then plus 4y1 plus 4y3 plus 4y5 plus plus 4yn, right? Minus 1, n minus 1, close the bracket, then plus 2 open bracket y2 plus y4, amen, y4 plus plus yn minus 2, right? Then close the big bracket. Okay. Yeah. So we are going to use this formula for this particular question. Is that clear? Just write it down. We are going to somewhere. Okay. So far, so good. So now, what we need to do here is, in the definition, we have h equals to b minus what? A all over n 2n, where xi is equals to a plus ih, true or false? Okay, it's true, right? So now we want to consider the interval. How can we obtain our h? Since h here is simple as ABC, then our why not is not difficult. I will tell you our n, amen? Our n. Okay, so now let's look at it together. This is the interval, true or false. If we have integral 0 to this, you can now see that let us have our number line. See that this is 0 to 6, right? It means this integral is running from 0 to 6. So in between 0 and 6, what are the real numbers? We have 1, we have 2, we have 3, we have 4, we have 5. It means 1, 2, 3, 4, 5, 6. So this implies that your n is equals to what? 6. Are you following? Any question? Because we want to do something, please, I hope you are there with your calculator. Calculator is necessary. Calculator is necessary. Please, hope you are there with your calculator. Okay? Okay. So if you agree with me, let's proceed. So here, it means our h is equals to, this is our a, true or false. Then this is our b. So 6 minus 0, n is equals to 6. Then this is 6 all over 6. This is equals to what? 1, right? Do you agree with me? So this implies that our h is equals to 1. Okay? Amen? H is equals to 1. So let us have the diagram. Is that clear? So now the x, let us have x. X. You know, the x, what do I mean by the x? Is what I have, that is the interval. Our x naught, x1, x2, that is xi is equals to a plus ih. Yeah. So our x is 0, amen. Then we have 0. Oh, let me just leave it like this. 0, 1, 2, 3, 4, 5, and 6. All right, it's 12. 1, 2, 3, 4, 5, 6. Okay. Yeah. So this is what we are going to do. Now, what we need to do here is look at the integral. The integral here is dx all over 1 plus x squared, right? This is the integral, true or false? True or false? It's true, right? Okay. This is the integral, right? Okay. So it implies that, we can rewrite this way, 1 all over 1 plus x squared times dx. So this is the function, right? This is the function. So this implies that anywhere you see x inside this function, you are going to substitute in 0, 1, and any answer it gives you, that is your y. Is that clear? So for us to obtain our y naught, y1, y2, it means your y is equals to this. Is equals to 1 all over 1 plus x squared. So this means that this is how we are going to, it means 1 all over 1 plus, here is 0, right? Y naught, x. So 0 raised to the power 2, amen? Okay? So now this is going to give us what? This is 0, 1 plus 1 is 1.0000, yeah, 0. Okay? So this is our y. So this implies that our y, okay, let me bring it down here. This is our y. So here is our y naught. This is how we are going to do it. Then, any question? Then, do you have any question? Please get your calculators ready. So now let's consider 1 here. So it means anywhere you see x, you write 1. X over 1 plus 1, 2 of us. 1 all over. Here, let's write 2. So, here is 2. So, here you are going to have 0.50 y1. If you have any question, let's move to x is square, right? So 1 plus 2 raised to the power, that is 1 all over 1 plus 2 raised to the power. This is the same thing as 1 all over, this is 4, 1 all over 5. True or false? Huh? True or false? It's true. So here will give us 1 all over 5, which is 0.20000. Am I right? Huh? Are you following? Then the same thing applicable here. The same thing applicable here. 3. This is y2, y3. Then here will be 1 all over 1 plus. This is 1 all over 10, right? Because here will be raised to the power 3. 3 raised to the power 2. Which is 9 plus this 10, right? So this is equals to 0.10000. Okay? Then 4, the same thing applicable. 1 all over 1 plus x squared. This will be equals to 1 all over, because there will be 16, then 16 plus 1, because if you substitute in 4, there will be 16, 16 plus 1 is what? Okay, so let's do it this way. Put 2 square, oh, sorry, 1 square, raised to the power 1, then here is raised to the power 2. Here is raised to the power 3. Here is raised to the power 4. Right? So here will be what? 16 plus 1, 17. So what should be the answer? You are supposed to have 0.588. Press your calculator. 235. This is Y4. Any question, please? Yeah. Any question? Do you have any question? Okay. Then I'm going to have this is Y5. 1 all over 1 plus 5 raised to the power 2. And this will be 25 plus 1. 1 all over 26. This is equals to, it will give us 0.03884 Then the last but not the least is 1 all over 1 plus 6 squared equals to, this is 36 plus 1 all over 37, right? So here we are going to have 0.02 70270. This is Y6. Okay, yeah. So this is how you are going to prepare a diagram to solve for. This. So now at this point, what we need here is for us to substitute these values into the formula. That is what we are going to do. Is that clear? That is what we are going to do. So now, in this formula, you don't need a prophet. Let me clean this up. Let us come up with the main formula. This is integral 0 to 6 dx all over 1 plus x squared is equals to h all over 3. Amen? Okay. H all over 3. So far so good. Integral, open bracket, y naught plus, I told you that your interval n, your n is 6, two of us. So instead of n here, we write y6, close bracket, plus 4, right? Then open bracket, 1, y1 plus y3 plus y5, right? Plus y5. Okay? The reason why we stop at y5 here is if you substitute when we have yn minus 1 and your n is 6, it means y6 minus 1 will give you y what? 5. So this is where you are going to stop. So we stop here, then close the bracket, come here, plus 2, open bracket, the same thing applicable. When you put 6 here, 6 minus 2, we stop at 4. So open 4, close the bracket. So you can now see that we have shortened this long formula, reduce it to this form, and this is what we are going to use. Are you following? So let's proceed Let's proceed. Please inform others to be part of this class because this this might be one of your questions. Yeah. So I can claim this, right? So now let us substitute here. Let's substitute using this diagram. So here will now be equals to our h is what? 1, right? 1 all over 3, open bracket, our y naught, this is 1.00000, then plus y6 is 0.0270270, right? Hope you are following. Then close the bracket plus 4 open bracket y1. y1 is this 0.5000, then plus y3 is this, amen, 10000, then plus y5 is this, right? y5 is 0.0384615, right? Close the brackets, then plus 2 open bracket y2. Hope you are following. Are you following? Please get set with your calculator because I will give you work to do. Get set with your calculator. Get set with your calculator. Make sure you write all these things out because it will be part of your note. Okay, so let's proceed. So y2 is this 0.20000, then plus y4 is 0.588235, amen. Then we close the brackets, and as you can see that all the y's are used here, two of us. Y naught is this, y1 is this, y2 is this, this y4 is this, right? And y5 is this. Then y6 is this. Okay. So I am try to add this. Try to add what is inside there. What is inside there? What is inside there? Please, waiting for you. I'm waiting for you. Try to add it. So I'll just write the final answer. You try to add it. And mind you, after adding it, use it to multiply. You multiply. After adding this bracket, use to multiply this, and adding this bracket, use to multiply this. add this, then after that you add everything together, divide it by 3. So the final answer will be 1.366. I will just write the final answer, 1.366, 1734. Yeah, 1734. I don't know whether there is a mistake, but just do your own. Is that clear? Try and do your own. So that is that. Is there any question? If there is no question, let us move to another example. Please, you can also send stars. I'll be very grateful. Yeah, you can also send stars. I'll be very grateful. Like, comment, share. Make sure all of you should share this class on your platform. Okay, so let's consider another example. Let us consider another example. Let's consider another example. Okay. Let's consider another example. Is that clear? Let us consider another example. Okay. Okay. Yeah. Another example. Evaluate integral 1.00 1.40 square root of x dx. Yeah. To 7 decimal places using Simpson's rule. Simpson's using Simpson's 1/3 rule. Amen. Okay. Already, I know some of you are just coming. Some of you are just coming. Okay. So the most important thing here is for us to know the intervals. That is, let's write solution first. We know that let us have is running from 1.00 to 1.4. So we have to know the numbers in between 1.00 and 1.40. Is that clear? So let us go ahead and begin to. After this, we have, after 1.00, we have 1.0667. Then we also have 334, sorry. Then we also have you can now see that it's approaching this 1.2001. It's approaching 1.40. Then we also have 1.2668. Okay, so let me just okay. Then we also have 1.335, 1.3350, triple 3. Then the last but not the least, you can now see that it has approached this 1.4002. Yeah. So in between these numbers, we have this. So 1, 2, 3, 4, 5, 6. Can you see now? So it means your n is what? 6. True or false? Your n is 6. Is that clear? Your n is 6. So let's move further. So we are going to do the same thing. Is that clear? The same thing. We'll do the same thing here. So it means let us have a diagram. X. Is that clear? X. It means n is where n is equals to 6. Then our h is b minus a all over 6, right? This is equals to our b is 1.40. This is our b. Then a is 1.00 all over 6. 1 should be the answer. We are going to have 0.00667. And this is what we are supposed to have. Is that clear? Are you following? Okay. This is what we are supposed to have. So let's move further to consider where is okay. The same approach. That is 1.00. Is that clear? So it means our y will be equals to the function here. The function here is what? Is square root of x. So y is equals to square root of x. Then what we need to do is we have to substitute this inside here. Is that clear? Let us substitute this. So y equals to. Is that clear? We have to substitute this here. So square root of 1.00. And the square root of 1.00 is still 1.00. Is that clear? Press your calculator. Press your calculator. Just press your calculator. Okay. Then we move to this, right? yn when n is 0, right? Okay. N is 0, we have this. In short, you can see how the number 0, no problem. Then 1.0667 minus square root of 1.0667 is equals to, press your calculator. This will going to give us 1.0328. This is y1. y1. I hope you are following. Any question? Any question, please? You have any question? Okay. Then let's proceed further. Let's proceed further to consider this 1.1334, right? 1.1334. So square root of 1.1334 will give us square root of 1.1334 will give us 1.0646, right? This is y2. Okay. So consider this 1.2001, then square root of 1.2001. This is equals to square root of 1.2001. We're going to give us 1.0955. This is y3. Press your calculator to confirm it. Is that clear? Make sure you press your calculator to confirm all this. Press your calculator to confirm all this. Hope you are following and you are enjoying the class, right? Okay, so let's move further to consider this, right? 1.2668, right? Okay, let's cover this. So square root of 1.2668 now will be equals to 1.2668 plus 1.1255, y4. Then please take note of this thing we are doing. It's part of the exam question. I'll not tell you again. If you like, be serious. It will be part of the exam. Then let's consider this 1.3335, then square root of 1.3335 is equals to, if you press your calculator, this will give you 1.1548. This is y5. Then the last but not the least is 1.4002, right? Then square root of 1.4002 is equals to 1.1833. This is y6. So this is how you are going to prepare table. If you have any question, please ask. Yeah. Any question? Or you don't understand, please ask your question. Ask. Ask your question if you know you don't understand. Okay. So far, so good. I think by my time we have 15 minutes left. So hope you are seeing what is on the board. You said we should convert it to, yeah, Abdullahi, ask your question, please. I'm waiting. You said you have a question. Ask. Ask your question. I'm waiting, please. Mahmoud, ask your question. Mahmoud, you are not typing, no. Type your question. Type your question. Okay, how do they get these 6 numbers? I thought I made it clear now. If we have assuming the integral is from the definite integral, assuming we have 0 to 4, I believe that you are just coming. Go to the number line, it means the interval is running from 0 to where? 4. So here is your origin, 0, right? This is 4. So now, in between 0 and 4, what are the numbers that will, from 0, it will approach until you get to 4? Is that clear? So now it means 0, 1, 2 of us, 2, 3, 4. So you can now see that. Here we have 1.00. This is the starting, down to 1.40. So you have to look for numbers that are in between this and this. There are numbers that are missing here. True or false? There are numbers that are missing here. That you will see numbers to get closer or close to these particular numbers. So it means there are 6 numbers. True or false? So have I answered your question, Abdul? Mahmoud? Okay. Please don't forget to share. Don't forget to share. It's very important. So far, so good. So, don't need the prophet to tell us. So what we need to do, our H is 0.0667. Then it means our here will now be integral 1.0, right? 1.0 to 1.40 square root of x. The x is equals to, sometimes you will see approximate sign, no problem. H, your H is to 1/3 rule now, Simpsons 1/3 rule, true or false? Your H is given as what? 0.0667 all over 3. Then we make use of the previous formula that we used, which you have taken it down. True or false? You know that you have taken it down. True or false? So it means y naught y35, right? Here is y naught plus yn, then plus 4 open bracket y1 plus y3 plus y5, true or false? Then plus 2 open bracket y2 plus y4, and we close the bracket, isn't it? True or false? It's true, right? So what we need to do here is for us to come here, and this is equals to 0.0667 all over 3, and then open bracket, what is our y naught? Our y naught is 1.000, then yn, which is 6. So n is 6 already, so let us write 6 here. So 6 is what? 1.1833, right? Plus 4 open bracket y1 is this. y1 is 1.0328 plus y3 is this 1.0955, then plus y5 is this 1.1548, close the brackets, then plus 2 open bracket y2 is 1.0646, y4 is this 1.1255. So can you see now? You can now see that I did not repeat any of the y's, true or false. So you have to be very careful when imputing all these values. Yeah, there are specific ways. So go and find out how you can get those numbers. Mahmoud. I did not arrive the numbers. The 1.00. That 1.0 is the same thing as 1. Even if you put 1.00 now, is it not the same thing? It's the same thing now. So yeah, I give you people 3 minutes to impute what is inside the bracket, and I use it to multiply this amount and divide it by 3. The first 5 people are going to give you 2 marks, and your time has started. Add this, multiply it by 4, add this, multiply it by 2. Then use this figure to, then after adding everything, use it to multiply what is here, divide it by 3. I give you 3 minutes, 2 marks. I'm waiting for you. The first 5 students. Your time have started though. Your time have started. So I'm waiting for you. I'm going to give you 2 marks. I'll give you 2 marks. I'm waiting for you. Zimo Abdul, you said your answer is 1.4600. Are you sure? Mahmoud, you said your answer is 1.4600. Are you sure? No, no. Yeah. Make sure you are using it to multiply 0 point. What is inside the after summation? What is inside the bracket? Use it to multiply 0.0667. Then divide it by 3. So I don't think you have that. Are you sure? One minute more. Take your time and do it. You people are giving me wrong answers. You are typing the same thing because your friend is typing it. You just follow your friend to type the same thing. People are very funny. I don't think you are sure. It's like you people, you don't know what you are doing. 98.5802. No, it cannot give you. Okay, your time is up. Nobody got the answer. I will write out the answer, then take your time. Yeah, the 905 to 7 decimal places. 1, 2, 3, 4, 5, 6, 7. And you see now. So that is the answer. And I'll give you assignments. And that assignment, I'm going to, you will submit it on Tuesday in the class. Very important. 0.43. You are just writing, you copied from me, football fury. You just copied my answer. So I will not give you marks. So write down this assignment. Write down this assignment. Assignment, take it down. Take this assignment down. Assignment. Okay. Evaluate integral 0 to 1 x raised to power 2 all over 1 plus x raised to the power 3 dx. Using Simpsons, one-third rule. By dividing the range, amen, of integration into 4 equal parts. 4 equal parts. Already I've made it easy. I've stated it into 4 equal parts. It means your interval, your n is equals to 4. Your n is equals to 4. So just find the numbers in between 0 and what? 1. So you are submitting it on Tuesday in the class. Thank you and God bless you for your time. Please don't forget to like, comment, share, and may God bless you. Yeah, I love you guys. Bye-bye. Till on Tuesday. Bye. Have a wonderful day and weekend.